Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
I told you that base 2 is usually called binary.
Yeah.
Okay, base 2 binary. Um, Base 8 is octal, and so on. So for instance, if you are converting base 10 is denary or something. If you are converting base 10 to other bases, what you need to do is start dividing that number by that base you're converting it to. So for instance, I want to convert 13 to base 2, so I will start dividing 13 by 2. 13 divided by 2, what will it be? Say that. Pardon? 13? That's 6 remainder 1. That's what you mean? 6 remainder 1, is that what you said?
Yeah.
In fact, these remainders are very important, so you should take note of them. 6 remainder 1. Then you just keep on dividing by 2. Divided by 2 again, what does it give you? Say that again. 3 remainder what? Remainder nothing, remainder 0, right?
Yes.
You divide again by 2, you have to keep dividing. What does it give you?
1.
1 remainder 1. Once it is smaller than 2, you can just move. Pardon? If you like, you might want to divide by 2 again. It becomes 0 remainder 1 and so on. But see, once you get a number that is smaller than 2, you now write out these numbers starting from the last to the first. So this is what we're going to write out. We're going to write out this from last to first. In other words, we're going to write 1101. That's how to read binary numbers. So it means 13 in base 10, which is a normal way of counting, is equal to 1101 in base 2. Can I try another one?
Yeah.
Okay. So I'll call this example 1. Example A. Let's try example B. You may want to convert 17 in base 10 to base 4. So what do you do? Divide 17 by 4 and keep writing out the remainders. So that will give us 17 divided by 4.
4 remainder 1.
So 17 divided by 4 is going to be 4 remainder 1. All right. Divided by 4 is 4 remainder 1. Okay. Divided by what again?
4.
4 again. That gives you what?
1 remainder 0.
1 remainder 0. Okay, once you get a number that is smaller than 4, this 4 you are using to divide it, you write out those numbers from the last to the first.
101.
101. So 17 in base 10 is equal to 101 in base 4. Okay. These numbers will be really large, so there's another way I will suggest you do it. So this is what I was saying. You see this question you are giving here? 213 in base 4 multiplied by 234, 23 in base 4. There are two ways to do it. You can convert both of them to base 10, multiply out, and then you now convert back to base 4. But let me show you how to convert numbers from a different base to base 10. Remember, all these ones are from base 10 to a different base. From base 10 to a different base, which could be base 2, base 3, base 4, from base 10 to a different base. But now we want to start from base something to base 10. So I'm going to title it on this column. Okay, let me draw a line. Okay, just a moment. All right, so I will call this one B, converting from a base to base 10. Converting from any given base to base 10. Let me use the examples I have here so that you see that they will still give us back to that value. Let me write this 1101 base 2. I want to change it back to base 10. Pardon?
Yeah, I got no. Continue.
All right, so for example, 1, that's example A. 1, so then let me say right properly. It's in base 2. I want to change it back to base 10. Will it be in base 10? What do we do?
B divided by 10.
No, not really. There's a different way to do this one. It is when you are changing from base 10 to something that you divide by that thing. But if you are changing from that to base 10, it's a different way. Are you ready for it?
Yeah.
Okay, these numbers, you number them starting from the right. You number them with 0, 1, 2, 3. Starting from the right. Is that what I did?
Yeah.
Okay, so it is in base what, by the way?
2.
Base 2. So you begin to pick these two. 2 raised to power each of these stuff. So 2 raised to power 3, for instance. Let me use the red pen so that you see. 2 raised to power 3, then times 1. After that, you add it to 2 raised to power this one, 2, then times 3. Just a moment. 2 raised to the power 2, don't worry, you pick it, let me pick up my pen. 2 raised to the power 2, then times 1.
Times.
Oh, so that should be it's a plus, there should be a plus in between, so that we can add up. Plus 2 raised to the power 2 times 1. Okay, times 1. Then plus this one now will be 2 raised to the power what?
But I don't understand.
Oh, okay. I said this power you are using, this base, the base should be raised to each of those powers. What is the base we are converting from?
2.
Base 2. So write out the 2. After you have numbered the 0, 1, 2, 3, from the right, number as you are moving towards the left. 0, 1, 2, 3. Is that understood?
Yes.
So pick those the base. The base times the power you have assigned to it, or base raised to the power you have assigned to it times the number. The base raised to the power you have assigned to it times the number. The base raised to the power you have assigned to it times the number. the base raised to the power you've assigned to it times the number. So, for instance,
Hello?
yeah,
Hello?
yeah, I'm here. Let's go. For instance, I've done this first one. 2 raised to the power 3 times 1. 2 raised to the power. I hope you can hear me. I hope you can hear me.
Yeah, yeah, yeah.
2 raised to the power 3 times 1. That's this first one. 2 raised to the power 2 times 1. That's the second one. So I'm asking you the third one, what should I write?
And raised to power 1 times 0.
Beautiful. 2 raised to the power 1 times 0. So the next one will be 2 raised to the power 1, then times 0. You know? And then we still have another one, plus. The last one will be what?
2 raised to power 0 plus 1.
2 raised to the power 0 times 1. 2 raised to the power 0
And
times 1. You add up all of them. Let's see if it will give us back where we started from. What is 2 raised to the power 3?
8.
8, good. 8 times 1 is 8. Beautiful. Allow you're impressing me. So we have 8. This is 8 plus. This second one is what?
4.
4 plus. This one will be what?
0.
0, because anything times 0 is 0 plus.
1.
How did you come about 1?
Anything raised to power 0 is 1.
Beautiful. And 1 times 1 is 1. Interesting. Let's add up. What do we get?
13.
13. That's what we started with. Remember, it was 13 that we changed to 13 from base 10. We changed it to base 2, and we got this number 11012. So from 1101 in base 2, if we change it back to base 10, we get back the 13. Is that clear?
Yeah.
Okay, let me do a few more before we take more examples. Let's see another example. Another example. Okay. 2102 in base 3, or 20123. Let me just put it like that. 20122 in base 3. Let's convert it to base 10. So what do we do? What's the first thing we should do?
We number them from the back.
Okay, beautiful. So let me use the red pen again. We number them from the units 0, 1, 2, 3, 4. And then we begin to do what? 3 raised to the power, each of them times the number they are under. 3 raised to the power 4 times 2
times
plus 3 raised to the power 3 times 0 plus 3 raised to the power 1 and 2 times 1 plus 3 raised to the power 1 times 2 plus 3 raised to the power 0 times 2. Did I miss anyone? 3 raised to the power 4 times 2, 3 raised to the power 3 times 0, 3 raised to the power 2 times 1, 3 raised to the power 1 times 2, 3 raised to the power 0 times 2. Alright, that's all. So let's simplify. What is 3 raised to the power 4? That's a large number. Wow, that's really large. 3 raised to the power 27 times, that's 81.
81 times
2. That would be
162.
162, okay. So we have 162 plus the whole of it will be 0, isn't it?
Yeah.
You know why? Anything times 0 is 0. So this place is 0. Plus, what about this one? 9.
9.
Plus this one?
6.
6. Plus this one?
2.
Pardon? 2, right?
Yes.
Okay. Because 3 raised to the power 0 is 1 times 2 is 2. Let's add up. We have this, we give 170, 179.
179.
So it's 179. Go to the next page. I need to introduce a slightly different one.
The next page.
Just the next page. I deliberately left those spaces. If the thing contains a fraction like 1011.110 in base 2, you can still change it to base 10. You do the same thing we did. You number from here 0, 1, 2, 3. Do you understand?
Yeah.
The way you're numbering the decimal part, you don't have 0, you start with -1, -2, -3, and so on. -1, -2, -3. Did you hear that?
Yes.
So you do the same thing we did. Shall we?
Yeah.
Okay, let's go. The first will be what? 2 raised to the power 3 times 1
3.
plus
2 raised to the power times 0.
times 2, is it? 2 raised to the power 0 times what? Oh, sorry. 2 raised to the power 3, 2 raised to the power 2, sorry. 2 raised to the power 2 times 0. 2 raised to the power 2 times 0 plus what again?
Power 1 times 1.
2 raised to the power 1 times 1, yes. Plus
2 raised to the power 0 times 1.
2 raised to the power 0 times 1. Alright. That's for the whole number part. Then you need to also write out the decimal part. The decimal part, so we put a dot here. We put our big dot. The decimal part is, let me use a different color. 1 raised to the power what?
1 raised to.
I'm coming back, I'm back to the decimal part now. Oh, sorry, 2 raised to the power, see me, it should be 2 raised to the power what?
2 raised to the power minus 1.
Minus 1 times 1, okay. Then plus 2 raised to the power minus 2 times, 2 raised to the power minus 2 times what?
Times 1.
Times 1 again, okay. Plus again, 2 raised to the power minus 3
2 raised to the power minus 3 times 0.
times 0, okay. These ones, you're going to write them in fraction. Anyway, they will show as fractions. Oh, I wasted this page. Let me reduce this. Let me reduce this so I can write it on that same page. Plus 2 raised to power 0, minus 3 times 0. Okay, let's start adding. Let's add up the whole number part, the yellow part. So what do we have? Pardon? I'm waiting for you to give me the answers. 2 raised to power 3 is 8 now.
Yes.
This is 8 plus 0 plus 2 plus 1 for the yellow part. Then the blue part, we put a dot. Two raised to power minus 1 is what?
But yeah, okay. The answer for the whole number is 11.
The answer for the whole number is 11. Yeah, for the blue part now. Do you know what 2 raised to power minus 1 is?
1 over 2.
1 over 2 times 1 is 1 over 2. That's what I just wrote. Then plus
Plus 2 over times 1.
this is what I'm asking you to give me. What is 2 raised to power minus 2?
Over 2.
What's 2 raised to power minus 2? Let me remind you of your indices. If you have a raised to power minus x, it's the same thing as 1 over a.
1 over 4. So 1 over 4.
1 over 4, okay, 1 over 4. So 2 raised to power minus 2 is equal to 1 over 2 raised to power 2, so that's 1 over 4 plus 1 over 4. Do we have any other one? Do you know I don't need to bother about this one because you give 0 anyways?
Yeah.
So if you like, you can just write plus 0. And then final answer. 11 whole number. Then this 1 over 2 plus 1 over 4, that's 3 over 4, right?
Yes.
3/4. Okay, 11 whole number, 3/4, or 11 whole number and 3/4. Of course, you can write it as 11.275.
11.7.
11.75, sorry. 11.75 in base 10. When you are working on number basis, any number you write, you need to indicate the base because it could mean a different thing in another base.
Yeah.
And those in computing make use of it a lot, so they need to know which base you are talking about. Okay. Let me write it properly. No time. Okay, this is because it should indicated 11 whole number, 0.75 in base 10. All right. Is it getting better and clearer?
Yes.
Okay, for subtraction, look at this. If you're given something like 35 minus 18, all in base 10. If it is in base 10, you don't need to write the base 10. We already know it's in base 10. Now, how do you do it? Can you solve it? Let me see. Solve it properly. 35 in base 10 minus 18 in base 10. Let's go. All right, I like what you're doing. Okay, interesting. Now I know what you did was you said 5 minus 8, because 5 is smaller than 8. You came to 3 and you borrowed 1, isn't it? Isn't it?
Yeah.
By the way, that one you borrowed, you actually called, that one you borrowed from 3, you actually called it 10. And you put it together with 5. 10 plus 5 gives 15. Gives what? 15. And then you said 15 minus 8. That's how you came about 7. I'm saying this because you're going to apply the same principle when you are working in other bases. Well, first of all, 5 minus 8 is smaller, so you came to 3, you collected 1. That one you collected, because we are solving in base 10. Anything you collect from here, you call it 10. So you called it 10 and added to 5, it became 15. And then you did 15 minus 8, that's 7. And what is left after you collected the one from here will be 2. And 2 minus 1 gives 17. Now that is because it is in base 10. What about if it is in other bases? Now let me write it in something in a different base. Assuming you have 35, this same 35 minus, I'm going to write 32 minus 15 in base 6. Okay. 32 minus 15 in base 6. 32 minus 15 in base 6. You are going to apply the same principle. 32 minus 15, all of them are in base 6. Apply the same principle. And let's solve it. Minus. So, let's go. Can you be audible?
Yeah.
2 minus 5, 2 is smaller, isn't it?
Yeah.
You will come to 3 and collect 1. And when you collect 1, what will be left? 2, isn't it?
Yeah.
2 will be left. Good. Okay, 2 will be left. But that one you collected, what are you going to call it? You are working in base 6. Just like the one you collected from here, you called it 10, and you added to 5, it became 15. Because you're working in base 6, the one you are going to collect from 3, you are going to call it 6 and add to this. 6 plus 2 will give you what?
8.
So you now say 8 minus 5. Interesting. So 8 minus 5. Well, good. So what's 8 minus 5?
3.
Good. Okay, so what is left? 2 minus 1.
Yeah.
2 minus 1 is 1, isn't it? So the answer is 13 in base 6. All right, please try this before 13 in base 6. You're going to try another one. I'm just using a different color so that it doesn't look like the number itself. Try this. Let me give you in base 1. This base 1 can be funny. Base 2. Let me give you numbers in base 2. 1, 1, 0, 1, 0, 1, 1. Okay, it's becoming too many. Okay, let me even. All right. I should have given you something else. Okay. Let me space it out a bit. How many zeros? 4 zeros and 1. Let me space it out a bit so that when you're writing, you can write better. 1 0 0 0 1. No, 4 0 0 1 minus 1 1 1 1. Okay, let's do this. All of them are in base 2. in base 2. You are subtracting. Okay, I love that. I love that. 1 minus 1 is 0. Good. So 0 minus 1. Hmm? 0 is smaller than 1. And you have come to here, nothing to borrow. You've come to here, nothing to borrow. You've come to here, nothing to borrow. You are coming straight to this final one. Why is it erased? Sorry, I wrote something there, but it's not showing at the end. Let me write it properly. Is it showing now? All right.
Yeah.
So, we are, first of all, 1 minus 1 is 0, correct? 0 minus 1, 0 is small. We've come to here, nothing to borrow. We've come to here, nothing to borrow. We've come to here, nothing to borrow. We are coming to here. But before I do that, do this first of all, because it is always with base 10 that it's easier to understand this. Do this first of all. Let me write normal numbers in base 10. Let me write 2003 minus, okay, let me call it 3003. 3003 minus 1, what am I writing? Yeah, 485 minus 485. Can you solve this? All in base 10.
Okay.
Normal base 10. Solve it and be telling me what you are doing, because it's the same principle you're going to apply here. Okay. I think what you try to do is 3 minus 5. Cannot. You came to here, nothing to borrow. Came to here, nothing to borrow, and you came straight to here. So you borrowed 2. You put it here. I like that. You borrowed 1 from here, and you took it to here 10. You struck out, and 9. Good. You put it there again. You borrowed again, and 9 is left. And then you took it down to here now, where you now have 13. All right, that's the principle. Okay. So 13 minus 5 is 8. 9 minus 8 is 1. 9 minus 4 is 5. Beautiful. And then you brought down 2. Interesting. That's the same principle you're going to apply. Remember you said 3 minus 5 is smaller. You went to here, nothing to borrow, nothing to borrow. You came to here, you borrowed 1. 2 is now left. That 1, you put it together with 0, it became 10. You collected 1 away from it. 9 is now left. You took it to here, 10. You collected 1 from it. 9 is now left. You took the 1 to here, it became 13. 13 minus 5, 8. Now 9 left minus 8, 1. 9 left minus 4, 5, and so on. So apply it here. All of them are in base 2. So anything you borrow is 2. Don't forget, anything you borrow is 2. Apply it here. You can use a different color of marker so that when you are writing, because it's a bit tiny. Alternatively, zoom. I hope you have zoomed in very well so that you can see it better.
Yeah.
Beautiful, beautiful. I'm really impressed with what you're doing. This is lovely. No, this is, you're coming straight to 1, isn't it? No. All of them are in base 2. This is not 10.
Sorry.
Just undo. Just, okay, or you can erase. Yeah, don't worry. It's better. 1 minus 1, you wrote 0. 0 minus 1, 0 is smaller. You came to here, nothing to borrow. You came to here, nothing to borrow. You came to here, nothing to borrow. You are coming straight to here. Yeah. And you borrowed it, what will be left?
0.
0. So you write a 0. You can, yeah, beautiful. Just undo. Let me use a different color so that it doesn't look like what you're writing. You can use yellow. Or maybe because the way you have zoomed, you won't be able to pick another color. Can you? All right, that's 0. Good. 0 is now left. So let me write it at the top part. 0 is now left. So you've collected the 1. Beautiful. You put it here. It is 2. 2 plus 0 is 2. I hope you know. Not 20. It's 2. Do you understand? Because whatever you borrow from here, you are adding it to what you have here. Whatever you borrow from here, you add it to what you have here. Oh, sorry, whatever you... And then you took 1 away, right? What is left? 1. Interesting. You put it here. 2. You took 1 away from it again. 1 is left. Beautiful. You put it here. 2. You took 1 away from it. 1 is left. Then you put it here. You put it here now.
Oh, sorry.
Oh, yeah. 2. Good. Yes. So you do 2 minus 1, 1. Okay, so go ahead. Beautiful. All in base 2. That's the answer. Okay. Finally do this one before I really let you go on this. Yours is can be tricky. Do this one now. Let me call it 50. No, what number can I give? Let me call it 23. Maybe 1, 2 to 3 minus 203 minus 14, all in base 5. All in base 5. Okay, yeah. Let's go. Interesting. Interesting. Lovely. Interesting. You are simply on fire. Okay, go ahead and do your subtraction. Are you still there? You collected 1, and whatever you collect, because it's in base 5, you call it 5. You put it here, that becomes 5. 5 plus 0 is 5, and you collected 1 again from 5. 4 will be left, and you put the one, that one you collect is 5, because you're working in base 5. That 5 plus 3 now gives us 8. So what you now have is 8. Okay, that's cool. So you did 8 minus 4, which is 4. 4 minus 1, which is 3. And then you brought down the 1. 1. Okay. That's the answer. Like I said, it must be in base. You must indicate the base you worked in. So in base 5. Okay. That should be good on this. Yeah. So that's about addition, subtraction, multiplication, and division of number in other bases. And I said if you have 43 in base 10 times 35 in base 10, of course, You know what to do using long multiplication. 5 times 3 is 15. You wrote 5 and you carried 1 to this place, right? Because it is 15, you wrote only 5 and you carried 1 to this place. You do the same thing. 5 times 4 is 20, and you added the 1, 21, you wrote 1 and carried 2, or rather the 2, since there's nothing else to write, you just wrote it 215, 21, or 215. Okay, so the same thing. 3 times 3 is 9, nothing to carry. 3 times 4 is 12, you just wrote it, and you added. And I want to also see how you're adding. 5, nothing here, you brought it down. 1 plus 2 is 10. You wrote 0 and you carried 1 to this place. 2 plus 1, then plus 2, altogether 5, then 1. This is how you got 1,505. All right, the same principle is what we apply when you are adding or multiplying numbers in bases. The only thing is you must convert each of the answers you get to that base. Let me give you an example. Assuming we are multiplying 23 by, can we use this same example? Okay, let's use this same example. 43 times 35 in base 6 now. Let me write it. 43 times 35. Now they are now in base 6, no longer in base 10. All of them are now in base 6, in base 6, in base 6. So let's multiply out again as we did earlier. So you will say 5 times 3, isn't it?
Yeah.
And that gives what? 18. Now, you can't write 18 because it is in base 6, it's not in base 10. So each of the answers you get, especially if it is more than 6, you have to change it to base 6. So we change 18 to base 6.
Wait, 5 times 3 is...
5 times 3 is actually 15, sorry. So we change 15 to base 3, to base 6. Yes, 5 times 3 is 15. We change 15 to base 6. That's what I'm trying to say. Because all the numbers are all in base 6. So change 15 to base 6. You know how to do it now. 6 divided by 15 is 2 remainder 3, isn't it?
Yeah.
Am I right?
Yeah.
2 remainder 3.
Yeah.
2 remainder 3.
Yeah.
Now you are going to, which of course will give us 23 or 23. We actually call it 23. So what I'm saying is 15, let me write it so that it will be clear. 15 in base 10 is actually 23 in base 6. Did you see that?
Yeah.
15 in base 10 is actually 23 in base 6. As you can see, 2, 3. 2, 3. You got that? 2, 3. You understand? Okay, let me write this remainder with a different color so that it doesn't look like a number. So 2 remainder 3. Oh, sorry, maybe a red will even be fine. 2 remainder 3, which gives us 23. So now, since it's giving us 2, 3, we will write in the answer section, we're going to write 3. And we carry 2. Just like you would have written, just like you wrote 5. When you did 5 times 3, it gave you 15. You wrote 5 and you carried 1, isn't it?
Yeah.
So we also write 3 and we carry 2. We're carrying 2 to this side. We're carrying 2 to here. And again, we do 5 times 4. What does it give?
20.
20 plus 2.
22.
So we first of all change the 22 to base 6 because these calculations are all in base 6. So we change 22 to base 6. 22 to base 6. Remember what to do. 6 into 22 will give us 3 remainder what?
3. 4.
3 remainder 4, yeah. 3 remainder 4. So which is 34, isn't it? Or 3, 4. We actually call it 3, 4. If it is another basis, you don't read it like you read in base 10. You read out the digits. So 22 in base 10 is actually 3, 4 in base 6. So what do we write here? Since it is 3, 4, we write 4 now, is it not? We are writing 4 and we carry, yeah, I like that. Okay, yeah, there's nowhere else to carry it, so you just write 3, 4, that's cool. Let me just write it better so that it can be arranged properly. So, but that's cool, 3, 4. So go ahead with the rest. It's just that there's not enough space. I would have asked you to go ahead with the rest. Okay, just go ahead. I'll be helping you to do the conversion here. So I think the next one you do will be 3 times 3, isn't it?
Yes.
3 times 3 gives what?
9.
9. Then are you going to write 9?
No.
What do you do to the 9?
Divide 9 by 6.
Okay, you change the 9 to base 6. That's by dividing by 6. You're right. So we are changing the 9 to base 6. That will give us...
1 remainder 3.
Interesting. So that's 1 remainder 3. 1 remainder 3. Interesting. 1 remainder 3. So what are we going to write? Write it.
9.
Since it's 1 remainder 3, that means, so we write 3 and we carry 1. All right. We carry 1, and then you also say again 3 times 4.
4 is 4 plus 1 is 10. Divide by 6.
Excellent. Let me do it in this small space where we do rough work. Hold on, let me do it in this small space so that 3 times, oh, hold on, you've already done it. 3 times 4 is 12. Did you add the 1?
Yes.
13. Did you divide 13 by 6? 2 remainder 1. You are right. Wow, you are so fast. I love the speed. That's correct. You know, because 3 times 4 is 13, and then you added the 1 from the other side. So that will be 2 remainder. So you can now add. When you add, no, you can't. It can't be 7. Even when you're adding, you do the same thing because it's in base 6. Once it is bigger than 6, you have to change to base 6. All right, that's 2 remainder 1. You are right, which is 21. Beautiful. Okay, so when you are adding everything up. So like I said, when you're adding, you should also be careful about the stuff. So you brought 3 down. You are going to say 4 plus 3. 4 plus 3 is what?
7.
So you have to change 7 to base 6. 7 to base 6 will give you what? Without wasting our time.
1 remainder 1.
Interesting. So 1 remainder 1. So you write 1 and carry 1. I love this. You are really on fire. 1 remainder 1. So you're bringing the 1 there. Excellent. Now, very good. So 1 plus 3 plus 1, altogether 5, and then 2. So this is the answer in base 6. You must write this base 6. Now, I want you to use this method. It's faster, so that's why it is recommended. Use this method to answer that question again.
Already answered that.
We've already answered it, but if you use it, you will get the answer faster. So we move forward. I think that's cool. All right.
Can you pull out what's the question?
It was, I think, this way we got the question on page 1. Let me zoom it in very well. This was a question. Question number 3, where you are asked to simplify 213 in base 4 times 23 in base 4. Have you seen it in page 3, in page 1? On page 1 rather.
Yes.
Okay, so I would recommend this method instead of the other one. You have to first of all convert to base 10 before you multiply and convert back to base 6. You know, that's the method one of the methods I told you. You convert the number to base 10. There are actually 2 methods, but that's a longer way to do it. You know. You convert this to base, this 213 in base 4, convert it to base 10, convert 23 again to base 10, multiply out, and then you now convert the answer back to base 4. That's a long method. So I think this is shorter now, isn't it?
Yeah.
Where you just multiply out the numbers. So I don't want us to waste that time. You just multiply 213 by 23, all in base 4. So we're not going to do it, you know. I said there's no need, or do you want to try it? There's no need. Let's move on to the next, okay? Okay, you should be able to answer this question now. The sum of 4 numbers is 124 in base 5. What is the average expressed in base 5? The sum of 4 numbers is 1214 in base 1214 in base 5. What is the average expressed in base 5? There are 4 numbers. There are 4 numbers, and the total is 1214 in base 5. How do you find an average, by the way? Is it not total divided by number of data?
Yes.
How many are they?
4.
So we have to use the total divided by 4 to get the average, isn't it?
Yes.
So we simply do 121 in base 5 divided by 4.
Yeah.
Does it make sense?
Yes.
All right, go to the newest page. Let's do that. 121 in base. What is that again? 121 in base. 121 what? Please get the number.
1214 base 5 divided by 4.
1214 in base 5 divided by 4. That's what we're basically going to do. 1214 in base 5 divided by 4. Okay, so the easier way to do this thing is change this to base 10, divide by 4, and change your answer back to base 5. Let's do that very quickly. You already know how to do it, so let me just do it. 0, 1, 2, 3, right?
Yeah.
So we simply do 5 raised to the power 3 times 1 plus 5 raised to the power 2 times 2 plus 5 raised to the power 1 times 1 plus 5 raised to the power 0 times 4. We are changing it to base 10, right?
Yeah.
This is equal to, we're changing all of this to base 10. This is equal to 125, yeah? Let me just write it quickly since I have a stylus. 125 plus 50. Hold on, let me just write it very quickly. Plus 50. I'm sure you would definitely trash this question. It's very easy. Plus 5 plus, what does this final one give you?
4.
4, because 5 raised to the power 0 is 1. 1 times 4 is 4. Okay, so it gives 4.
Yeah.
You're right. So 125 plus 50, that's 175. Plus 5, that is
The answer is
184, right?
Yes.
184. So 184, that's in base 10 now, divided by 4. That will give us 46. 46 in base 10. So you just change 46 in base 10 back to base 5, isn't it? It's very easy. So 46 in base 10, we change it to base 4. 4 into here.
But we change it to base 5.
Into base 5, sorry, to base 5. Change 46 in base 10 to base 5. I'm proud of you. 5 into here will give us 8. No, 9 remainder 1.
9.
9 remainder 1, right?
Yeah.
9 remainder 1. 9 remainder 1. What again? 5 into here will give us
1.
1 remainder 4. 1 remainder 4. So the answer will be what?
1
141. So the answer is 141.
5.
Is it in the option?
Uh,
In base 5.
yes, in the option.
Yeah, cool. That's just it. I think it's getting more interesting.
Yeah.
You can do it. That's cool. Okay. Time is usually of essence in this kind of exam. So the fastest method is always recommended, not just the easiest, but the fastest. It might be easy, but if it is not fast, you need to try to use the faster method. So there's another way this can be done, which is faster. The example we did earlier, 1214 in base 5 divided by 4. Now what you can do is you apply long division. The long division method, let me show you what I mean. We are dividing 1214 in base 5. Let me write it down here. 1214, okay, let me write it better. 1214 in base 5. We are dividing it by base 4. Oh, sorry, dividing it by 4. We are dividing by 4. So, just like we do in long division or division, 12, first of all, 1 divided by 4, 1 is smaller than 4. So we have to carry the two numbers together. But this is in base 5. Any number we are taking to join the other one must be 5. In other words, we must multiply it by 5. So this one we are taking to join 2 should be multiplied by 5. Remember, 1 divided by 4, 1 is smaller, so we need to join this one with 2. But this one must be multiplied by 5. So first of all, we say 1 times 5, that gives us 5. 5 plus 2, that's 7. So we're doing 7 divided by 4. 7 divided by 4. And 7 divided by 4 is 1, remainder 3. So we have 1, remainder 3. 1, remainder 3. We have 3 remaining. Let me write the 3 here. These 3 remaining must be multiplied by 5. So 3 times 5 is 15. And we're joining it with this one. 3 times 5 is 15. Joining it with this one, it becomes 16. Because 3 times 5 is 15. 15 plus 1 is 16. So we say 16 divided by 4. 16 divided by 4, that gives us 4. We have 4 here. What is left is 4. No remainder. Remember, 16 divided by 4 is 4, no remainder. So what is left here is 4. And 4 divided by 4 is 1. Is 1, all in base 5. So this is faster. In base 5. Which is the answer. Therefore, 1214 in base 5 divided by 4 is equal to 141 in base 5. Let's try yet another example. 1110 in base 3 divided by 3. We apply the same method. Let me rule a line. We're dividing it by 3. So we have 3 here, and we have 1110 in base 3. So 1 divided by 3, 1 is smaller than 3, so we have to join it to the next one. And anything we are joining must be multiplied by 1. 1 times 3 is 3. So 3 plus 1, that we are joining it together. 3 plus 1 is 4. 3 plus 1 is 4. Remember, first of all, 1 times 3 is 3. Then 3 to join together with the other one. 3 plus 1 is 4. It's 4. So we do 4 divided by 3. 4 divided by 3 will give us 1. Remainder 1. 1 remainder 1, there's a 1 remaining. That 1 remaining, we multiply it by 3. 1 times 3 is 3. We join it together with this one, that gives us 4. Also 4 divided by 3. 4 divided by 3 again, that's 1. Remainder 1. Remainder 1. 1 is remaining. That 1 that is remaining, we multiply it by 3. That gives us 3. 3, we join it to 0. 3 plus 0 is 3. It's 3. So 3 divided by 3 is 1. So the answer is 1. So the answer is 111 in base 3. Therefore, 1110 in base 3 divided by 3 will give us 111 in base 3. Okay, let's see this one. 2102 in base 3. 2102 in base 3 divided by 5. So we apply the division method again. Let's see. By dividing by 5, we have 2102 in base 3. Divided by 5. So we go again. 2 divided by 5. 2 is smaller than 5, so we join it together with 1. But anything we're joining, we have to consider that we first of all do 2 times 3, because it's in base 5. So 2 times 3 is 6. 6 plus 1 is 7. So this whole place is 7. 7 divided by 5. 7 divided by 5 is 1. Remainder 2. So there's a 2 remaining. We put it here. 2 is remaining. This 2 that is remaining, we multiply by 3. 2 times 3 is 6. We join it together with 0. 6 plus 0 is 6. Remember, 2 times 3 is 6. 6 plus 0 is 6. So 6 divided by 5. 6 divided by 5 is also 1. Gives us 1. Remainder 1. So there's 1 remaining. Put it here. This 1 remaining, we multiply by 3. Anything we have, we multiply by the base. 1 times 3 is 3. 3 plus 2 is 5. 5 divided by 5 gives us 1. So the answer is 111 in base 3. Therefore, 2102 in base 3 divided by 5 will give us 111 in base 3. So the method is easy and faster. And it's recommended for an aptitude test like this, which requires speed. Remember, 1214 in base 5 divided by 4. You are dividing by 4, so you say 1 divided by 4, 1 is smaller. You join it together with the 2. But this 1 must be multiplied by 5. 1 times 5 is 5, because 5 is a base. 1 times 5 is 5, then you add it to the 2. That's 7. So you do 7 divided by 4. 7 divided by 4, that's 1, remainder 3. You write the 3. The 3, you have to multiply by 5. So 3 times 5 is 15. 15 plus this 1, you are joining it with, that's 16. 16 divided by 4 is 4, no remainder. So we just have 4 left. 4 divided by 4 is 1. So the answer is 141. And that's also what we did here. 1, 0 in base 3 divided by 3. So we do 1 divided by 3. 1 is smaller, so we join it together with this one. First of all, you have to multiply it by 3 because it's in base 3. So 1 times 3 is 3, plus this one, that gives us 4. So this whole place is 4. 4 divided by 3, that's 1. Remainder 1, that's what we wrote here. This one that is remaining, you multiply by 3. So 1 times 3 is 3, plus this one we are joining it, plus this one, that's 4. Also 4 divided by 3 will give you 1, remainder 1. The remainder 1, you put it here again. And you have to multiply this 1 by 3 because the base is 3. 1 times 3 is 3. You join it together with 0. That's 1 plus 1 times 3. 1 times 3 is 3. Join it together with 0. That means 3 plus 0 is 3. 3 plus 0 is 3. So 3 divided by 3 will give us 1. So the answer is 1, 1, 1 in base 3. Okay. Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.